My name is Habib and my topic is belousov zhebotinsky. For the experiment, we prepare solution. 10 grams of sodium bromide are dissolved in 100 milliliter of distilled water. It is formed mixedly, and for the second one, 2 grams of malonic acid are dissolved and 75 milliliter of 10% sulfuric acid in 100 milliliter volumetric flask is added. After that, 1 gram sodium bromide is added and the solution is topped to 100 milliliters. It is formed mixed very well, and now it is into the bar of H2SO4. In addition to the other solution, heroin solution is needed that usually has a concentration of 0.05 moles per liter. The amount of all solution is sufficient to repeat the experiment several times. The solution at 1 and 2 are mixed in the ratio of 1:1. 25 milliliters of both solution were mixed on the ratio of 1:1. When the solution mix, bromine is formed immediately, which slow down reaction after while, so that it recommended to cover the beaker with a watch glass. When the solution is colorless, the farrowing can be added. In the case I added 1.6 milliliter. In the other runs, it was simply added until the color was intense enough to be visibly seen clearly. In the beginning, the period, which is the duration between the color changes, was almost 2 minutes. The color has changed now. Now it has become different, and solution, this is the reason why it has been heated, and increase the speed of the reaction at the temperature between 40 to 45 degrees Celsius to make the reaction fast, to make the temperature rise to. The color has now changed and it is firmly mixed. At the end of the reaction, the solution stays blue. At the end, the color of the solution is blue. In next, the smaller amount of solution was prepared. In the case of 10 milliliter, each solution were mixed. Then fair oven was added and the solution was heated a bit to make the reaction faster. Then it was added to a petri dish and left to sit. The reaction is very slow, so it's shown time lapse as it is seen in the time lapse of 50x. The solution should not be heated because otherwise the formation of bubbles is very quick, and when the solution makes the effect start again. Here it can be seen after the solution has cooled down. With every run there are different patterns because of the lot of factor on the formation. So for every run there are different effect on their formation. In the following shot, the thickness of the layer was cotton and held. Here are clear image of the waves can be seen, which also prove that a thin layer are given better effect. These oscillatory reactions are recognized in the middle of the mid-19th century because they looked as if they changed between the state without the loss of energy, and it was difficult at first to replicate them. Thank you. My next topic is glycolytic oscillation. As you can see in this video, how the oscillation are taking place in the yeast cell. So all the life forms they obtain their energy by the process of glycolysis. Yeast cell are amongst the most common basic under certain condition. The concentration of glycolytic intermediates in yeast cell can oscillate. Individual yeast cell in the suspension can synchronize their oscillation to get in phase with each other. Although the glycolytic oscillation originate to the upper part of the glycolytic chain, the signaling agent in the synchronization appear to be acetaldehyde, a membrane permeating metabolite at the bottom of an anaerobic part of a glycolytic chain. Here we address the issue how a metabolic presentation a quantitative model for glycolytic oscillation and their synchronization in terms of chemical kinetics. We show that in essence the common acetaldehyde concentration can be modeled as a small perturbation on the pacemaker whose effect on the period of an oscillation of a cell in the same suspension is indeed such a synchronization develop. So this is what you see in any cell, how a glycolytic oscillation takes place. So these are my topics for the medical biophysics. Thank you.